Hi, in this section, I will go over reciprocal identities, quotient identities, Pythagorean identities, cofunction identities, even and odd identities, and then I will use these identities to find the 6 trigonometric functions and show how these identities can simplify a trigonometric expression. So it's good to know these identities because in the next section, we're going to learn how to prove an identity. So you got to prove one side equals to the right side. So yeah, it's good to know how you can manipulate your equation with these identities. So let's start with the first one. We have what's called the reciprocal identity, which is sine of u equals 1 of cosecant u. Now, I know you in previous lectures, you know that sine u can be many things, right? What I mean is like sine can be a lot of things. It could be y over radius. It could also be, remember SOHCAHTOA? It could also be opposite over hypotenuse, right? And then you have this, sine of u is 1 over cosecant u. The reason why you have all these formulas is because you're going to prove an identity and then you got to decide which one's the best one. So you'll see what I mean when we do the examples. So here are these. I don't think I'm going to say it out loud because I will probably give you a PDF which you can print out. So just either press pause or just look at it real quick. And then we have the quotient identity, which is pretty simple. Sine of u over cosine of u, cotangent u, cosine of u over divided by sine of u. That's something we've seen and done before. And then we have Pythagorean identities. First one is sine square of u plus cosine square of u equals 1. And then the second one is 1 plus tangent square of u equals secant square of u. And then 1 plus cotangent square of u equals cosecant square of u. I think all you have to remember is this one, number 1, because if you divide everything by sine square or cosine square, you're going to get either equation 1 or equation 2. So if you don't believe me, go ahead and try it out. So what I mean is if you can know this one, you're okay. So what I mean is, like, let's say you want to divide everything by sine square of u. And you'll see that either could be equation, when you simplify it's either going to be equation 1 or equation 2. So sine square of u over sine square of u is 1 plus cosine square of u over sine square of u. That's like saying x over y, which is technically cotangent. And then 1 over sine square of u is like, well, 1 over sine of u is what? Cosecant of u. Since there's a 2 of them, because there's a square, that's going to be cosecant square. Okay, so if you did that, and then if you divide everything by cosine square of u, you would get equation 2. So that's how I remember that one. So that's Pythagorean. Now we have cofunction identity. Like I said, there's a lot, so I'm not going to read it out loud. You can just press pause or print out the PDF. And then we have even or odd identities. So it's good to know these because they will come. Okay. Now let's do some examples. I think we have exactly a total of, let's see, a total of 8 examples, but these aren't too bad. So example 1 says use the value of secant u of -3 over 2 and tan of u is greater than 0, meaning it's positive, tangent is positive, to find the values of all 6 trigonometric functions. So what do we have? So we got to find all 6 trigonometric functions. So if you go back to your notes, you can, first off, you get it, maybe it's good to know what what quadrant are you in the unit circle? So it's, okay, so let's figure out where is, they said that tangent is greater than 0, meaning positive. So where in the unit circle, I mean, which quadrant in the unit circle is tangent positive? Quadrant 1, yes. Quadrant 2, no, because cosine is negative and y is positive. That would make it a negative tangent. What about quadrant 3? Yes, you know why? Because cosine is negative and sine is negative. So when you do y over x, you get a positive. Okay, so it's either 1 or 3. But the thing is, secant u. So if you go back to your notes, one of the formula was cosine of u equals 1 over secant u. So we're going to use that formula because we can find cosine u, right? So let's do that. So cosine of u equals 1 over secant u. So secant of u is negative 3 over 2. And now we have what's called a compound fraction, right? So you're going to multiply top and bottom by 2. So this is 2 over, and then this is negative 3. So you get negative 2 over 3. This is very important because we could actually draw the triangle and determine which quadrant we're going to use, because remember, if you recall in your previous lecture, cosine is also the same thing as x over radius. So if our x is negative 2, we know that it's going to be our theta is going to be in quadrant 3. So go ahead and draw a triangle in quadrant 3. So they said the x value is negative 2, so this value is negative 2. And then our radius is 3, so the radius is also the hypotenuse. From this triangle, we can also find the y value, and it's definitely still going to be negative. So we can use the Pythagorean theorem, right? A squared plus b squared. So one of our legs is negative 2 square. The other one is b square, and then the other one is 3 square. So negative 2 square is 4 plus b square equals 9 square. I mean, not 9 square, it's 9. Subtract 4. You get b squared equals 9 minus 4 is 5. And then to solve for b, you're going to take the square root of both sides. So you get b equals square root of 5. But keep in mind that we're in quadrant 3, so the y value is definitely going to be negative. Put in negative 5 here. And then now we have our x and y in our radius. So now we can find sine of theta. I mean sine of u. Sine of u is simply y over x, right? I mean y over radius. So what's our y value? It's negative radical 5 over 3. Good. And then let's find tan of u. So tan of u is y over x, right? Y over x. So our y value is negative radical 5. And our x value is negative 2. So that becomes positive radical 5 over 2. Okay. Secant of u is just the reciprocal of cosine. So here's our cosine. The reciprocal of that would be negative 3 over 2. Right? Yes. And cosecant of u is going to be the reciprocal of sine, because I remember there's an s here, so I know it's the reciprocal of sine. So it's going to be negative 3 over radical 5. And then you can't have a radical in the denominator, so you're going to rationalize top and bottom by radical 5. So that's negative 3 radical 5 over 5, right? And then how much do we have? 1, 2, 3, 4, 5. We need one more, and I think we'll find that's cotan. So cotan of u is just the reciprocal of tan, so that would be 2 radical 5, and then rationalize the denominator. So that's going to be 2 radical 5 over 5. Okay, so that's how you find your 6th trigonometric function using only when you're given secant of u and then tan of u. So it's good to always draw the triangle. Example 2, it says simplify. So in example 2, it just says simplify sine of x cosine square of x minus sine of x. This is a good example when we're doing verifying identities where you have to make one side equal to the other side. So let's see here. Look at sine. We have sine of x cosine square of x minus sine of x. I always ask myself, is there anything you can take out? And it looks like I could take out something, right? It looks like we could take out sine of x. But I think I can also take out a negative sign. Yes, I tried taking out, okay, I did try when I first did this problem, I did try taking out only a positive sine x. It almost worked. It didn't work because when you took out just a positive sine of x, you would get 1 minus cosine square x, and I mean 1 plus cosine square x, which couldn't be one of our identities. So that's why you kind of have to like tweak it a little, just make sure to make you have one of your identities. So I'm going to take out a negative sine of x, not a positive sine of x. And then this is going to be negative cosine square of x, right? Because we want a positive sine x cosine square x. And then this will mean we need a positive 1. Good. Okay, so now let's see if we can simplify this even better. Can we simplify negative sine of x? You could say something like it's like 1 over cosecant x, but that wouldn't. I want to be in terms only in cosine of x and sine of x, so I'm just going to leave it as negative sine of x. Now, this thing I can actually simplify using the Pythagorean identity, sine square x plus cosine square x equals 1. And how do I use this? Well, you're probably thinking, well, this doesn't look like this. No, it doesn't. But you can tweak it a little to make it look like this. So what if I subtract cosine square x from both sides? So you would get sine of square of x equals 1 minus cosine square of x. So this is equivalent to the same thing. It's also the same thing as negative cosine square of x plus 1, right? It's the same thing. So what you can do is replace this whole thing with sine square of x, right? Because this equals this, so we can replace this with that. And then when you multiply this out, you're going to get negative sine of x times sine square of x is going to be negative sine cube of x. And that's your final answer. That's the most simplified it can be. Example 3. Example 3, we have 2 parts. It says factor each expression. The first one says, they just say factor. They don't want you to actually solve for it, or you could simplify it. And then, so in part A, we have secant square theta minus 1. And then part B, we have 4 tan square theta plus tan theta minus 3. Okay, so I'll start with the first one. So we have secant square theta minus 1. This is actually a perfect square, believe it or not. This could be broken down as secant theta plus 1 and secant theta minus 1, right? Because it is a perfect square. So that's the most factor you can do. Now, part B, you have 4 tan square of theta plus tan of theta minus 3. It's just regular factoring. When you try to factor this, try to figure out, know all your factoring rules. So just looking at this, you always ask yourself, can you take anything out? Can you take out anything from this equation? Unfortunately, we can't. So then you have to figure out what factoring method can we use. We can't do simple factoring because of this 4, right? We have 3 terms, so we have to do either can't. So we have this 4 right here. So what does that mean? We have to use what's called bottoms up factoring. I don't know if you remember that, but it's bottom up factoring. It's also called the AC method. Okay, so you only use this method if there's a number other than 1 in front of the highest degree. So in our case, yes. So first step is rewrite the equation as if the 4 doesn't exist. So it's going to be tan square theta plus tan theta. And then what you're going to do is multiply 4 by -3. So that's -12. And then from here, we could just do regular simple factoring, right? So this is going to be tan theta. And then over here, we need 2 numbers that are multiplied. That'll give you -12. And added gives you +1, because there's an invisible 1 here. So that would mean we would have to do 4 and 3. And then I'll use +4 and -3, because when you multiply 4 and -3, you get -12, right? And when you add 4 plus -3, you get +1. Okay. Then what you're going to do is remember the 4 from the original problem. You're going to divide that by this 4 here, and then this -3. So this 4/4 becomes just tan theta plus 1. And then over here, this -3/4 can't be reduced fraction. So what you're going to do is just bring that 4 in front of tan. So if it can't be reduced, that's just why they call it bottoms up. I don't know why, but you just bring the 4 in front of tan. So that'd be 4 tan theta. And then the denominator disappears and you're just left with the numerator. So this is the most effective form it can be. Okay, so that's that one. Example 4 says factor cosecant square x minus cotangent x minus 3. So first, always check if you can take anything out. And I'm looking at that and we cannot take anything out. Now, what else could we do? So could we just go straight up to factoring? I wouldn't. I would actually simplify something as much. Simplify something. Try to use one of your identities to replace one of the factors, one of the equations. So we can't take anything out, but we can simplify this cosecant square x, right? If you recall that one of your Pythagorean identities, I think it was, this one. Right, we're going to use this one. So we're just going to replace cosecant x with 1 plus cotan. So that's what we're going to do. So cotan is the same thing as 1 plus cotan square x, and then just bring down the rest. So this is a negative cotan x minus 3, and simplify as much as you can. So what can we simplify? So we'll just leave the highest degree in for the first term. So that would be cotan square of x, and then we have negative cotan of x, and then we have a 1 and a negative 3. That is negative 2. And then from here, we could just do simple factoring, right? This is cotan of x. This is cotan of x. And then this is 2 and 1. And then this is negative 2. And then this is positive 1, right? Because negative 2 times positive 1 is negative 2, right? Negative 2 times positive 1 is positive 1 is negative 2. And then negative 2 plus 1 is negative 1. And that's it. You can't simplify it anymore. Okay. Number 5, example 5 says simplify sine of t or sin of t, cotan of t, and cosine of t, cos of t. Okay, so first off, can you take anything out? No, you can't, unfortunately. So we can't take anything out, but can we replace one of those sections with an identity? So starting with the sine of t. Not really. I mean, you could do the cosecant t, but I wouldn't do that because I want everything to be terms of cosine and sine of t. So I'll just leave it as sine of t for right now. Plus, what about cotan of t? Can you use one of your identities? Remember, if you call in your identities, cotangent of anything is the same thing as cosine of t over sine of t. And then you're going to times that by cosine of t, right? Then let's go ahead and simplify. So this is sine of t. And then cosine of t times cosine of t is cosecant square of t over sine t. Okay, now I know this looks tempting to put, we are adding fractions, right? So what do you need when you're adding fractions? You need what's called a common denominator, common denominator. So over here we have a sine t, and over here we have a 1. So our common denominator is sine of t. So over here we don't have to multiply anything else with sine of t because this already has a sine of t. But over here we have to multiply top and bottom by sine of t, right? So go ahead and do that. So if you do that, sine of t times sine of t, that's sine square of t plus cosine square of t, all over the common denominator, which is sine of t. Almost done with this problem. Now, can you somehow replace the numerator sine square t and cosine square t with an identity? Yes, right? It's one of your Pythagorean identities, sine square of t plus cosine square of t equals 1. So we'll do that. So we'll just replace this with 1 over sine of t. Now, is this the most simplified answer? No. You can simplify 1 over sine of t based on your identity. It's the same thing as cosecant t. Cosecant t. So this is your final answer. It's pretty cool how you can convert one thing and now it'd be in one term. Okay, example 6, perform the addition and simplify. So we have a fraction, sine theta divided by 1 plus cosine theta plus cosine theta over sine theta. So when you're adding fraction, what do you need? You need a common denominator, right? So our common denominator, if you can't really find one, you just have to, it's usually the multiples of 2. So our common denominator is 1 plus cosine of theta times it by sine of theta, right? So over here, what is it missing? It's missing a 1 plus cosine theta. Yeah, don't FOIL this out, just leave it as it is. So you have to multiply top and bottom by 1 plus cosine of theta. And then over here, what is this missing? It's missing a sine of theta, right? So multiply top and bottom by sine of theta. And then here as well. Okay, now simplify. So what's sine of theta times sine of theta? Sine square theta plus, and then over here you just FOIL, you're gonna have to FOIL it out. So 1 times cosine theta is cosine theta. And then cosine theta times cosine theta is cosine square theta. All over the common denominator, which is sine of theta times 1 plus cosine of theta, right? Okay, and then now let's simplify the numerator. So this whole thing, is there anything you can replace something with an identity? Yes. Well, first off, you can't take anything out. You can't factor anything out. But you can replace this sine square theta and cosine square theta. That equals 1. Remember, sine square theta plus cosine square theta equals 1. So that's going to be 1 plus cosine theta. And then on the bottom, you're left with sine theta times 1 plus cosine theta. Okay, now, is there anything else you can do? Is there anything you can cancel? I see something you can cancel. The thing that you can cancel is this whole thing, 1 plus cosine theta, right? So go ahead and cancel that. So on the top, you're left with just 1. And then on the bottom, you're just left with sine of theta. And then you can simplify 1 over sine of theta is the same thing as cosecant theta. And I just realized it's actually t, but it's okay. No, no, you're right. I mean theta. I was looking at the wrong problem. That's right. Everything is in terms of theta. So this is your final answer. Okay. 2 more examples, and then that's the end for this lecture. So on example 7 says rewrite 1 over 1 plus sine of x so that it is not in the fractional form. So how they don't want anything in a fraction. That's weird. Okay, so here we have this 1 plus sine of x. They don't want a fraction. That's what they're saying. So what we can do is, remember in radicals, to get rid of the square root, we multiply top and bottom by the conjugate. So we're going to do the same process. We're going to multiply top and bottom by the conjugate of the denominator. So the conjugate of the denominator is 1 minus sine of x. 1 minus sine of x. So if you multiply 1 by this whole thing, that's just going to be 1 minus sine of x. And then over here, 1 plus sine of x times 1 minus sine of x, you could FOIL it out 1 by 1, but there's a shortcut. It's called the perfect square. So it's going to be 1 square minus sine square of x. So 1 square is just 1 minus sine square of x, right? Now, it looks very tempting to just FOIL it out. And then, you know what? You could FOIL it out. I just realized something. There's an easier way So what I mean is 1 minus, on the top it just stays the same, and then on the bottom, this is a perfect square, right? Oh no, I'm wrong. Yeah, you can't just FOIL it out because this is so what I meant was, like, I thought I could just do 1 minus sine of x times 1 plus sine of x, and then this whole thing would cancel, then you're just left with 1 plus sine of x, and no, it wouldn't work out. But what could you do is, do you see this sine square theta? I mean sine square x? It's one of your special identities, right? Cosine square x plus sine square of x equals 1. So let's try to get sine square by itself. So that would be, if I move the sine square to the left, right, by subtracting both sides by sine square of x, this cancels. So you're just left with cosine square x equals 1 minus sine square of x. So you can just replace this entire thing with cosine square of x, right? So your equations could be 1 minus sine of x divided by cosine square x. Now, you have to simplify even more. This, remember, you're dividing cosine square x to each term. So what that means is you're dividing the 1 by cosine square x, and you're dividing the negative sine of x by cosine square x, right? So you can go ahead and write that out. So this would be 1 over cosine square of x minus sine of x over cosine square x. Okay, so now let's simplify. This 1 over cosine square x, what do we know? We know that secant x is the same thing as 1 over cosine of x, right? But there's two of them, right? Because remember, cosine square of x is the same thing as cosine of x times cosine of x. So that's like saying, so this would be not just one secant x, but two secant x. So that would be secant square of x. Okay, and then this, the negative sine of x is the same thing as negative sine of x over cosine of x times cosine of x, right? Because remember, I just explained cosine square of x is the same thing as cosine of x times cosine of x. So let's divide the sine of x with cosine x, and that would give you tan x, right? And then don't forget a minus. There's a minus, so that's why it's negative tan of x. And then over here, there's actually a 1 here. And then what do we know about 1 over cosine of x? That's the same thing as secant of x. So this becomes a secant of x. So this is your final answer. Okay. Now, you could do there's more than one ways you can do it, but I think eventually you're still going to get the same answer. Okay, so on number 8, example A says use substitution. Let me reread the problem. It says use substitution x equals 2 tan theta, where theta is less than 90 and then or pi over 2 and greater than 0. And and this is one very important. This is what's given, also given square root of 4 plus x squared. So we're just gonna have to do substitution and then simplify. So if they say that x is 2 tan of theta, so you can just say that it's 4 plus x, which is 2 tan of theta. And then it says you're going to square that. So that's going to be square root of 4 plus And then if you square this, this is going to be 4 tan square of theta. Okay, and then inside the radical, what can you do? You can actually factor out something. You can actually factor out the 4 because they both have a 4. So go ahead and take out a 4. So this is 4, and then this is going to be 1 plus tan square theta. Now, can you simplify using your identities? Yes, but you can simplify this, 1 plus tan square theta. So if you call back to your rules, 1 plus tan square of theta equals secant square theta. Okay, so this is going to be square root of 4 secant square theta. And then it's the square root of this whole thing, so that's just going to be square root of 4 is 2, and the square root of secant square theta is just going to be secant theta. And that's your final answer. Okay, so I hope you enjoyed this section and look forward for the new section, which is verifying identities. Okay, so you have a great day. Bye-bye.